In this tutorial, I'll explain about limits, tolerances and fits. In the universe, if you observe, no two things can be identical, they are only close to similar. In nature, if you observe, no two things can be identical, they are only closely similar. So that's why this statement is also true for manufacturing. So three elements, those three are man, machine and material, because skill of the person will change from person to person. So one person may be very good in operating the machine, another person may not be that much good. That's why this parameter will vary the components quality. Then coming to the machine efficiency will decrease as the life increases. So that's why the new machine will give suppose 90% efficiency. After 5 years it may give only 80% efficiency. If you are using the same machine over a period of 10 years, automatically the efficiency will change, then automatically the quality it is giving will differ from time to time. Even from today to tomorrow also the quality will vary. So that's why because of machine also we will get some difference in dimensions. Then material, suppose 40 CR8 is some steel material. So this particular material grade will not be same as one person is manufacturing in India and the person who is manufacturing in some US. Slight variation will be there, which is negligible, but that will affect the dimensions of the object. Suppose I want to manufacture some 40 dia rod. So I may not be in a position to manufacture exactly 40 diameter. This may be plus or minus 0.02 of 40. That means 40.02 or 39.98 I can manufacture. So that kind of differences we will get because of these three M's. So that's the effect of these three. We will get the variation in size. Now let us try to understand the hole and shaft system to understand the effect of the three M's. What is hole? Hole can be defined as an internal feature generated by removing the material from the workpiece. Suppose this is my initial workpiece. If I start removing, first I will draw some small, give a small sponge, then start removing the material like this. At one point of time I will stop removing the material, then this particular solid rod will become a hollow rod like this. This is the outer diameter, this is the inner diameter. This is called as hole. Next, what is shaft? Shaft can be defined as an external feature which is used to transmit torque from one end to the other end. That means generally shafts will be something like this, of some round cross section. Here I will apply the torque like this in the counterclockwise direction or clockwise direction, then automatically the same torque I will get the other end. So this kind of power transmission or torque transmission we can achieve by means of using a shaft. That we can define as a shaft. Next, what is basic size or nominal size? Basic size or the nominal size is the generally referred size with respect to which we can define the variations of the size. So basic size of a shaft is some 40. Exactly 40 I am not able to manufacture. This is slightly varied. This particular variation I have to show, with variation is suppose plus or minus 0.02. How to show this variation with respect to some standard dimension only, So that standard dimension we will call as basic size. Now I'll explain about limit system. To explain this limit system, first take this hole. This is the hole. This green color one is the shaft. Okay. Now, so basic size of the hole is varied like this. This is the minimum size. This is the maximum size. Suppose basic size is some 40. 40 I am not able to manufacture. I can manufacture up to 39.98 or 40.02. So this 39.98 is this particular size, minimum size. This 40.02 is the maximum size. Okay. So that is the variation in the hole that I am showing here, something like this. With respect to the shaft, this is the variation. This is the minimum shaft, this is the maximum shaft. Okay. But representing on the both sides, this is the center point. With respect to center, representing this variation on both the sides, top side and bottom side, is somewhat difficult to understand. That's why this total variation I will shift to only one side. So how to do that is, just slide this particular center hole downwards like this. Then this particular gap will go upwards. Observe here. Now this is shifted down. Then the total variation here I can represent on the top side only. Okay. So whatever total variation I am getting on the top side as well as on the bottom side, this total variation I am shifting only to the top side. Okay, that's what I am doing here by shifting this circle to downwards like this. Okay, that means this is the total variation in the shaft. Now coming to the hole, this is the half of the variation. Here another half is there. Now to represent it conveniently, assume that this shaft is touching this hole somewhere here. Okay, shift it to this place. Now this entire assembly you shift downwards such that this half of the portion of the variation in the hole will shift to the top side, and total variation you can see in the top side only. Okay, now shift it like this. Okay, now this is the total variation of the size for hole. This is the total variation in the size for shaft. Okay. Now you can clearly understand this hatching portion is with respect to hole, this hatching portion is with respect to shaft. Okay. Now this particular line is called as zero line. This is the zero line with respect to which we can explain the basic size or nominal size. Okay. Zero line is with respect to basic size. That means according to our standard according to our example just now we have taken, the basic size is 40. That means this line is representing 40 diameter. Okay. Now what are the standard other definitions? I'll explain one by one. Limits. Limits can be defined as the permissible variation in the dimensions that has to be allowed to account for 3Ms. So to account for 3Ms, anyway we have to allow some variation. We can't avoid that. Okay. Maximum and minimum variations are known as limits. Okay. Now observe, maximum size is called as upper limit. So here maximum size of the, so up to here this is the maximum size of the hole. So that is the maximum diameter, that we will call as upper limit. Maximum diameter of the hole or shaft we can call as upper limit. So with respect to hole, this is the maximum diameter. With respect to shaft, this is the maximum diameter. Okay, these are called as upper limits. Next, observe the lower limit. So lower limit means minimum size is called as lower limit. That may be with respect to hole or with respect to shaft. With respect to hole, if you observe, here to here, this particular area is the minimum hole. Here to here, this particular area is the minimum shaft. Observe here, this is maximum, this is minimum. Here also, this is maximum, this is minimum. Okay. Now what is zero line? Zero line is the general reference line representing the basic size. Okay. So the expressions are variations or deviations. We have to explain with respect to the zero line only. Okay. So here you can see the zero line clearly. Here the variation is 0, here to here. This is the zero line. It's touching the zero line means no variation. Now what is deviation? The algebraic difference between actual size and corresponding basic size is called as deviation. So basic size means that is with respect to zero line. Actual size means the variation, that may be maximum or that may be minimum. So whatever it might be. So that variation you can observe in the actual size, and basic size is constant, that is theoretical one. You can assume as that as the theoretical one. So that particular variation we will call as a deviation. Now what is upper deviation? Upper deviation means there is the algebraic difference between the actual size. Actual size means that may be maximum dia or minimum dia, but in this case to get the upper deviation, the actual size you have to assume as a maximum dia, and corresponding basic sizes with respect to zero line. That means this is the zero line and this is the maximum diameter. This particular difference we will call as upper deviation. Okay, upper deviation is always with respect to the maximum value, that you can remember. Now coming to the shaft, this is the zero line. Upper deviation is somewhere here with respect to maximum dia you have to measure. So maximum dia is here to here. So this particular small gap you can call as upper deviation. Okay. So this particular upper deviation will designate with capital ES for hole and small es for shaft. So ES means E cot superior. In that way we have to pronounce this. Okay. That is about upper deviation. Now coming to the lower deviation, it is the algebraic difference between the minimum limit, that means minimum dia. So for the shaft this is the minimum dia, this is the zero line. The algebraic difference between this basic size and this minimum dia is called as lower limit. Now observe here, lower limit is more for shaft. In the previous case it is upper limit is less. Here lower limit is more. Upper limit values, don't think that upper limit means that will be more. No, it's not like that. Okay. So here if you observe, the algebraic difference between basic size and corresponding minimum size, corresponding minimum limit. So that difference we will call as lower deviation. So here this is the lower deviation for shaft, this is the lower deviation for hole. So lower deviation will indicate with I. So capital EI is for hole, small ei for shaft. EI means E cot inferior. EI meaning is E cot inferior. Okay. Next, what is fundamental deviation? Fundamental deviation will give the location of the tolerance zone. So the difference between upper deviation and lower deviation we will call as tolerance. So this is the upper deviation, this is the lower deviation. This particular difference we will call as a tolerance. This is the tolerance zone. The location of the tolerance zone, this tolerance zone is located from the zero line at this particular distance. At this particular distance, this distance we will call as fundamental deviation. Okay. So now coming to the shaft. So this is the tolerance. This is the tolerance zone. This tolerance zone is at this much distance from the zero line. Here this tolerance zone distance from the zero line, to this tolerance zone distance you can indicate with the lower limit. Am I correct? This is lower limit. Here to here this distance is lower limit. That means fundamental deviation In this case, for a hole is lower deviation. In this particular case, in other case, that may become the upper deviation. Fundamental deviation will become the upper deviation. Suppose if you take the shaft, now observe, this is the tolerance zone. This location of the tolerance zone, at how much distance the tolerance zone is there from the zero line, that you can identify here with this particular distance. This particular distance is upper deviation. Upper deviation. Okay. So in this case, for a hole, fundamental deviation is the lower deviation, and for shaft, fundamental deviation is the upper deviation. In this way, we have to identify the fundamental deviation. Now, what is tolerance? Tolerance means the permissible variation in the basic size without losing the functionality of the object. Okay. So, always failure means don't think that the object has to break. It's not like that. When any mechanical component or machine is not satisfying its functionality, then assume that it is failed. Okay. So until whatever variation you are taking without disturbing its functionality, that particular allowable variance or permissible variation in the dimension, that means with respect to the basic size, is called as tolerance. Okay, it is the algebraic difference between the upper limit and lower limit. Now observe here, for this particular hole, this is the upper limit, this is the lower limit. The difference, this zone we will call as tolerance. This is the tolerance. Okay, for shaft, this is the upper limit, this is the lower limit. This particular difference we will call as tolerance. This is the tolerance zone. Okay, that's about tolerance. Now, what is allowance? Allowance means internal difference between the hole and shaft dimensions after their assembly is called as allowance. Now, the tolerance is with respect to hole or with respect to shaft. Okay, tolerance is individual for hole. The hole, that is the tolerance. For shaft, this is the tolerance. Something in this way. With respect to shaft and with respect to hole, we will discuss all those things: upper deviation, lower deviation, maximum limit, minimum limit, and all that. But coming to the allowance, when shaft is placed inside the hole, what is the difference of their dimensions? What is the internal difference of their dimensions? That difference we will call as allowance. Suppose internal difference is more, then very easily I can insert the shaft into the hole. Then that is called as clearance fit. Those fits I will explain later. But for the time being, you try to understand that allowance means internal difference between the dimensions of a hole and shaft when they are assembled. That is called as allowance. Now, what is the maximum material condition or MMC? So, maximum material condition means the feature contains maximum amount of material. The feature contains, that is important. This word contains is important. Suppose this is the round shaft, round rod. This is the round rod. I want to make a hole. From here I am starting. I go on increasing the size of the hole, something like this. Okay. Now, when hole is not there, this particular rod contains maximum material. When I start removing the material, that means when the hole size is increasing, whatever material it contains decreases. Am I correct or not? Okay. So here it has to contain max amount of material means this hole size must be minimum. contains maximum material. Material means hole size is minimum. Okay, so here this is the maximum hole size, this is the minimum hole size. So minimum hole size we have considered up to here. Okay, then that is with respect to hole, that is the minimum hole. Coming to the shaft, so this is the shaft. When I am doing machining on this particular shaft, if I start removing here, I will put the tool, cutting tool. If I go on increasing the depth of cut, then material it contains will decrease. Okay, it has to contain maximum material, means that is the maximum diameter I have to maintain. If I increase the depth of cut, material will be removed, I will get the minimum diameter, which is not suitable for this particular case. This particular case means maximum material I have to contain, that is the maximum material condition. Okay, so as a result of that, it contains the maximum material, means I will get the maximum diameter of the shaft. Maximum diameter of the shaft. In the maximum material condition, hole will, coming to the hole, size of the hole is minimum. Coming to the shaft, size of the shaft is maximum. Now what is allowance? Allowance is the difference of its dimensions, difference of its sizes between hole and shaft. So hole is minimum hole and shaft is maximum shaft. The difference between these two we will call as allowance here in this case. Now what is least material condition? In the least material condition, the feature contains minimum amount of material. Okay, now this is the rod. I am go on increasing the size of the hole. At one point of time, it contains least material. Least material means the hole size is more. Okay, that means maximum hole I will get, maximum size hole. Okay, this is shaft. I have to get least material. Least material means I have to do the machining. I have to increase the depth of cut. I have to do the machining. Then automatically shaft dia will become minimum. So for shaft, it is minimum size shaft. For hole, it contains least material, means hole size will increase. Maximum hole. So maximum hole minus minimum shaft. That is the allowance in LMC, least material condition. Now what is the fit? Fit means it is the relation between the mating parts. Okay. Now observe, this is the zero line. If hole is above the zero line, the tolerance zone of the hole, this is the tolerance zone of the hole, is above the zero line, and tolerance zone of the shaft is below the zero line, means you will get the clearance fit. Suppose if you take minimum hole and maximum shaft, in that case also you are getting some clearance. No, very easily you can insert the shaft into the hole. So that is the meaning of clearance fit. Now interference fit. Here hole size is less, shaft size is more. That is the interference fit. Transition fit means this is the hole, shaft size is varying from minimum to maximum, something like this. Okay, that is called as transition fit. Now definition of clearance fit is something like this. In this fit, maximum diameter of the shaft is less than the minimum diameter of the hole. Observe here, this is the maximum diameter. This is the minimum diameter of the hole. This is the maximum diameter of the shaft. This, even though it is maximum, very easily you can insert into the minimum hole. Then you will get a positive clearance. So allowance is now positive. That is the advantage of the clearance fit. Now observe the MMC condition. MMC condition means maximum material condition. In the maximum material condition, we will get the minimum hole. Material is maximum means we will get minimum hole minus maximum shaft. So maximum material the shaft has to contain, so diameter will be maximum. So here the clearance will be something like this. You will get the minimum clearance. In MMC we will get the minimum clearance. In LMC, in least material condition, we will get the maximum clearance. How it will be maximum? You observe here. So least material condition means the material must be less. Then automatically hole size will increase. So you have to take the maximum hole up to here and minimum shaft. Least material, that means material has to decrease. So as they go on removing the material, the shaft diameter decreases and we will get the minimum shaft. So this much clearance we will get here in the LMC. In the MMC, this is the clearance. In the LMC, this is the clearance. So clearance is maximum, no, in LMC. Now coming to the interference fit. In this fit, the minimum diameter of the shaft is greater than the maximum diameter of the hole. Maximum dia of the hole. So observe here. This is the maximum dia. Up to here, this is the maximum dia. This is the minimum dia of the hole. Sorry, this is the maximum dia of the hole. This is the minimum dia of the shaft. Even if you take the minimum dia and maximum hole, you are not able to insert the shaft into the hole. This hole is smaller than the shaft. Then in that case, automatically we will get interference. So the allowance between the hole and shaft is negative in this case. So that's why it's called as interference. Now what is the LMC condition? LMC condition gives the minimum interference. So here whatever interference you are getting, that will be minimum. Observe here, this here to here. That means maximum hole, minimum shaft. In that case, this much interference you will get. Okay. Now MMC. Observe the MMC condition. In that you will get the maximum interference up to here to here. This all is the interference zone. So maximum material condition means you will get the minimum hole. So maximum material, it has to contain. It has to contain the maximum material means automatically hole size will become minimum. And maximum shaft dia, it is containing maximum material means shaft dia will become maximum. So automatically you will get the maximum interference. Transition fit. Transition fit means it is varying from clearance to interference. So here it is clearance. Now here it is interference. So clearance to interference, it is varying something like this. So that kind of fit we will call it transition fit. So that means suppose one person X is manufacturing this particular typical component, then that will become clearance fit. Same component, suppose Y is manufacturing, that is becoming interference fit. Means typically from person to person it is varying from clearance to interference. That kind of fit we will call as a transition fit. Suppose X is manufacturing, he is getting clearance fit. Y is manufacturing, he is getting clearance fit. Then that kind of fit we will call as a clearance fit. That means always it is clearance only. There won't be any chance of getting clearance to interference. That is called a transition fit. So here at LMC, L1C is positive and clearance fit. At MMC, L1C is negative and interference fit. That means it is changing from positive to negative, that from LMC to MMC. That kind of fit we will call as a transition fit. This is brief introduction about the limits, tolerance and